The statement that solid aluminum 10, 12, and 14 American wire gauge conductors cannot be installed in a breaker in a subpanel is incorrect according to the National Electrical Code, specifically sections 110.13 and 240.4d. These sections outline the requirements and permissions for using aluminum conductors in electrical installations. Section 110.13 addresses the suitability of equipment for the specific installation, encompassing factors like voltage, current, and interrupting rating. It emphasizes that electrical equipment must be approved for the intended purpose. This means that when using aluminum conductors with circuit breakers in a subpanel, the equipment, including the circuit breakers and the panel itself, must be listed and labeled for use with aluminum conductors. This listing ensures that the materials are compatible and that the connection will be reliable and safe over time. Compatibility is essential because aluminum and copper, the most common conductor materials, have different properties. Aluminum expands and contracts more than copper with temperature changes. This difference in thermal expansion can lead to loose connections over time if the connectors and terminals are not designed to accommodate the movement. Furthermore, aluminum forms an oxide layer on its surface when exposed to air. This oxide layer is non-conductive and can increase resistance at the connection point if not properly addressed. To mitigate these issues, manufacturers produce circuit breakers and panels specifically designed for use with aluminum conductors. These devices often incorporate features like pressure plates and corrosion inhibitors to ensure a secure and reliable connection. The pressure plate helps maintain constant pressure on the conductor, compensating for thermal expansion and contraction. Corrosion inhibitors prevent the formation of aluminum oxide, maintaining a low resistance connection. Therefore, when using aluminum conductors in a subpanel, it is crucial to use circuit breakers and panels that are specifically listed and labeled for use with aluminum. This information is typically found on the equipment's label or in the manufacturer's specifications. Section 240.4d of the NEC deals with the protection of conductors against overcurrent. This section specifies the conditions under which the overcurrent protection device, such as a circuit breaker, must protect the conductor. The general rule is that overcurrent protection must be sized to protect the ampacity of the conductor. However, there are exceptions to this rule, particularly for small conductors like 10, 12, and 14 American wire gauge. Section 240.4d provides specific overcurrent protection requirements for these small conductors. For example, a 14 American wire gauge copper conductor is typically protected by a 15 amp circuit breaker, a 12 American wire gauge copper conductor is typically protected by a 20 amp circuit breaker, and a 10 American wire gauge copper conductor is typically protected by a 30 amp circuit breaker. These requirements are based on the ampacity of the conductors and the need to prevent them from overheating and potentially causing a fire. When using aluminum conductors, it is essential to consult the ampacity tables in the NEC to determine the appropriate overcurrent protection. Aluminum conductors typically have a lower ampacity than copper conductors of the same size. Therefore, an aluminum conductor may require a smaller overcurrent protection device than a copper conductor of the same size. For example, a 12 American wire gauge aluminum conductor may have an ampacity similar to that of a 14 American wire gauge copper conductor, and therefore may require a 15 amp circuit breaker for overcurrent protection. It is important to note that the NEC also permits the use of specific termination devices that are listed and labeled for use with both copper and aluminum conductors. These devices are often marked with the letters CU/AL, indicating that they are suitable for use with either copper or aluminum conductors. Using these listed and labeled termination devices is crucial for ensuring a safe and reliable connection. In addition to using the correct equipment and following the NEC requirements, it is also essential to follow good installation practices when working with aluminum conductors. This includes cleaning the conductor to remove any dirt or corrosion, applying a corrosion inhibitor to the conductor, and properly torquing the connection to the manufacturer's specifications. Proper torque is essential for ensuring a secure connection and preventing overheating. Over-torquing can damage the conductor or the equipment, while under-torquing can lead to loose connections and increased resistance. It is also important to avoid mixing copper and aluminum conductors in the same termination unless the equipment is specifically listed and labeled for such use. Mixing copper and aluminum can lead to galvanic corrosion, which can weaken the connection and increase resistance. In summary, solid aluminum 10, 12, and 14 American wire gauge conductors are permitted for use in circuit breakers and subpanels, provided that the equipment is listed and labeled for use with aluminum conductors, the overcurrent protection is sized correctly, and good installation practices are followed. Consulting the NEC and the manufacturer's specifications is essential for ensuring a safe and compliant installation. Always refer to the latest edition of the NEC and consult with a qualified electrician for any questions or concerns regarding electrical installations. Remember, electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Ignoring electrical codes and safe practices can lead to serious injury or even death. It is also important to be aware of any local codes or regulations that may apply to electrical installations in your area. Local codes may be more stringent than the NEC and may require additional precautions or equipment. Always check with your local building department or electrical inspector before starting any electrical work. Following these guidelines will help ensure a safe and reliable electrical installation. Specifically regarding the reference to NEC 110.13, it is essential to understand the implications of suitability of equipment. This section mandates that all electrical equipment used in an installation must be suitable for the specific environment and application. In the context of aluminum wiring, this means the circuit breakers, panels, and any other associated hardware must be explicitly designed and approved for use with aluminum conductors. This approval is typically indicated through listing and labeling by recognized testing laboratories like Underwriters Laboratories or Intertek. These listings signify that the equipment has undergone rigorous testing to ensure its safe and effective operation with aluminum wiring. Using equipment not specifically listed for aluminum wiring can lead to several problems. Firstly, dissimilar metals like copper and aluminum can create galvanic corrosion when in contact, leading to a breakdown of the connection and increased resistance. Secondly, the different thermal expansion rates of aluminum and copper can cause connections to loosen over time, again increasing resistance and potentially leading to overheating and fire hazards. Thirdly, improper terminations can damage the aluminum conductor, further compromising the connection. Therefore, strict adherence to NEC 110.13 is paramount when using aluminum wiring. Ensure all equipment is properly listed and labeled, and that installation practices are in accordance with the manufacturer's instructions. Regarding NEC 240.4d, it's crucial to delve into the specifics of overcurrent protection for conductors. This section addresses the allowable overcurrent protection for conductors, particularly small conductors like 14, 12, and 10 American wire gauge. The general rule is that conductors must be protected at their ampacity, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. However, 240.4d provides exceptions to this rule for small conductors. For example, a 14 American wire gauge copper conductor is typically protected by a 15 amp circuit breaker. A 12 American wire gauge copper conductor is typically protected by a 20 amp circuit breaker, and a 10 American wire gauge copper conductor is typically protected by a 30 amp circuit breaker. These values are based on the ampacity of the copper conductors. When dealing with aluminum conductors, the ampacity is generally lower than that of copper conductors of the same size. Therefore, the overcurrent protection device might need to be smaller than what would be used for a copper conductor. For instance, a 12 American wire gauge aluminum conductor might have an ampacity closer to that of a 14 American wire gauge copper conductor, and thus require a 15 amp circuit breaker for overcurrent protection. The NEC provides ampacity tables that specify the allowable ampacities for various conductor sizes and types, including aluminum. It is essential to consult these tables to determine the correct overcurrent protection for aluminum conductors. Furthermore, the type of termination used also plays a role. Terminations listed and labeled for use with both copper and aluminum conductors, often marked with CU/AL, must be used. These terminations are designed to accommodate the different properties of the two metals and ensure a reliable connection. Proper torque is also critical when terminating aluminum conductors. The manufacturer's instructions should be carefully followed to ensure the connection is neither too loose nor too tight. Over-torquing can damage the conductor, while under-torquing can lead to loose connections and overheating. In summary, while solid aluminum 10, 12, and 14 American wire gauge conductors are permitted in circuit breakers in subpanels, it is imperative to adhere to NEC 110.13 and 240.4d, use appropriately listed and labeled equipment, consult ampacity tables to determine correct overcurrent protection, and follow proper installation practices. Ignoring these guidelines can lead to unsafe conditions and potential hazards. It's always recommended to consult with a qualified electrician for any electrical work to ensure safety and compliance with all applicable codes and regulations. The NEC serves as the cornerstone of electrical safety, providing comprehensive guidelines for electrical installations. Its consistent application minimizes risks and ensures the reliable operation of electrical systems. Therefore, understanding and adhering to its provisions is paramount for anyone involved in electrical work. Always prioritize safety and consult with qualified professionals when needed.